Obviously, everybody is aware of the regulatory pressure for clean emissions, and the overriding question is how to comply in an economical manner. And ClearChem is the answer to that question. Didn't show the next slide, Bob, and I'll tell people a little bit about me. So, since I think they need to know I'm not qualified to talk about what I'm doing. Would you put the next slide up?
Sure.
I feel qualified to. Oops, hadn't shown yet.
Okay, I've got the first one shows the ClearChem system, then the next one says ClearChem low-cost emission control, and then we get into the costs and concerns.
I guess that the second one that I sent you a change, and I apparently.
Oh, okay. I may have missed putting the second one up. Sorry.
Not a problem. I was going to simply show our contact information and explain my background.
Well, why don't you explain that, and we'll make sure that everybody does get that information. I'm an ASME fellow with 45 years of successfully creating solutions for fossil fuel emissions, slagging, and corrosion. Those solutions include the MGO scrubbing process used at Eddystone and Crombie, and that was a recycle process where we made sulfuric acid. And the first cost-effective chemical additives for fireside slagging and SO3 control were one of my inventions. What we got in the way of the next slide, since we're approaching things a bit differently. Yeah, I've got costs and concerns up here now.
Well, I guess I can work around it.
Okay.
Let's go to that.
Yeah, we got that up here, then costs and concerns.
Yes.
And then the next one after that is
Bob,
yeah.
Excuse me, Bob, this is Ed Napierski. On our screens, we're not getting anything but the first slide being shown.
That's all I see.
All you see is the first first slide. Okay, so let's go into the share my desktop again here. Oh, okay. Apparently we've lost the internet service. So what we're going to have to do is, Jerry, is give a verbal summary here, and then we'll see that everybody gets a copy of the slides, and we've got our IT department working about getting us back in. But
okay.
Why don't you give us a verbal?
That makes it a little harder.
Yeah, it sure does.
Well, okay. What we're talking about is a technology we call ClearChem, and it's really the lowest cost capital option available, other than shutting down the power plant. And it uses widely available and low-cost reagent. ClearChem is the injection of finely sized calcium carbonate into the furnace using special injectors to maintain the micronized reagent as agglomerate-free particles. This reagent is typically a high solids, about 75%, fluid, stable, pumpable calcium carbonate dispersion. It's widely available, and people use it every day, and because it's used in coated paper, plastics, paint, and your toothpaste. If a potential ClearChem user has a scrubber and excess ball mill capacity, the dispersion could be made by the contract with an approved vendor, could be made for a lower cost boiler grade than the premium stuff that they use for paper. Could be made on site from, using a slipstream from the ball mill. Some of the industrial byproducts that are available, or even fly ash, could also be incorporated in the dispersion to further lower the reagent cost. The limestone slurries are also safer for personnel to handle and deploy than the competing reagents. The next slide I was going to show would go into some details about what the capital costs are, so I might as well read them to you. A typical installation is going to cost under $500,000. The operating cost to remove a ton of sulfur is somewhere in the range of $400 to $600 for each ton of SO2 mitigated. This compares with several times that for a DSI system. The capital cost for a DSI system is also an order of magnitude greater, and a dry scrubber is several orders of magnitude greater than what we're talking about. We're talking about a very small footprint, and easily handled material, and it's safe. All of a sudden we've made it.
Yeah, we got back on the internet here, so my apologies.
Those things happen. Thanks, Bob. This slide will help to give you a feel for the differences in total cost. Whoop.
Yeah, I just expanded it.
Thank you. What this is a 10-year cost for comparison for the three different types of options available: dry scrubbers, dry sorbent injection, and our ClearChem. Just basically the cost of capital and the cost of reagent. We've ignored the operating cost to simplify things, and we've also looked at it on as a function of load. On the left, you're looking at the dry scrubber. The next one down is the ClearChem, and it's significantly cheaper. Dry sorbent is very much more expensive, and the dry sorbent can be made less expensive by combining it with the ClearChem. ClearChem is a system for injecting the calcium carbonate into the furnace as a discrete fine particle. We're talking about 7/10 micron calcium carbonate particles is what we're injecting. And we have specialized injectors in order to keep the product from agglomerating. The objective is to get discrete particles.
How does that compare to the typical particles coming out of a ball mill, for instance?
The typical particles out of a ball mill are going to be about 20 microns. And you're looking at, here we're talking about 7/10 micron. What's significant, though, is that the 7/10 micron is going to give you 750,000 more particles per pound than the 20 micron. And the reason that's important is that it increases the probability of contact of a reagent particle with a pollutant particle. Remember, your pollutants are there in parts per million, so the more particles that you have, the better chance of getting them together.
So the slide shows that their economics is significantly better, and of course the reason it's better versus the dry scrubber, which is more efficient chemically at this point, and I haven't talked about that yet. Maybe that slide's still available. Guess well, let's go through this and do it that way. That is furnace sorbent injection. It's patented based on micronized calcium carbonate. We've seen no tube deposits, no impact on the ESP. The fly ash that you get is marketable, and you don't have to worry about pond leaching, which you get with the Trona. This is some of the results that we've seen. We've done 3 demonstrations in operating boilers. 84% SO2 capture at a calcium sulfur equal to 1.9. I want to make a big point here that the lower exit temperature will boost that capture. This was demonstrated actually by DOE back at in the Edgewater studies. And it does offer the potential, let me come back to that. We've seen HCl capture at about 75%, but our data on that's limited. We think we can do better. We know that it's very effective in terms of SO3 capture, which will help, obviously, in making mercury capture easy.
Now that means that you could possibly even use this where you do have a scrubber for your SO2, but you've got a plume problem with the SO3, and you could solve it this way rather than putting in a wet precipitator, right?
Yes. What you actually do, Bob, is if you have a scrubber, you can take full advantage of that. You can actually lower the temperature. It takes an investment, either in a little more air heater and retuning the boiler, or in diverting the feed water from the, heating the feed water instead of diverting steam to do it.
So somebody like TVA that was having a blue plume problem coming out of their scrubber, and invested $20 million or whatever it was in a wet precipitator, could potentially have avoided that capital and expense and just injected the fine limestone particles in the boiler.
Yeah, it definitely takes out the blue plume. But I was trying to make the point that you get an additional advantage when you take all the acids out ahead of the air heater, is that one, you can lower your flue gas temperature and gain some fuel efficiency and reduction, of course, in CO2 emissions. But once you've done that ahead of the scrubber, you're effectively going to increase your L over G, and that scrubber becomes more efficient. Mm-hmm. You get a double impact on your SO2. Not only do we take out a significant amount with the injection, but your scrubber then becomes more efficient. The other possibility that has not been really focused on, but power plants today are concerned about water issues and supply. Ed Levy's done a lot of interesting work on capturing the water from the flue gas, which is not insignificant. And that is enhanced, that the possibility of that's enhanced by taking the SO3 out, because now you don't have the corrosion issue.
Are you on there, Jerry?
Yeah.
Oh, okay. So we'll move to the next slide here now, or?
Yeah.
Okay.
I'm a little bit disorganized because of
yeah, I guess this was a preliminary rather than final presentation. I apologize there.
those things happen. Some of the other benefits that we offer is, as I just talked about briefly, the existing flue gas system can be more effective. We can use the existing calcium carbonate supply if you've got one. That involves a contract with the people who make these carbonate dispersions. But it will use an existing logistical setup and make the cost more attractive because you don't have freight. And there is also the potential to use reagents other than limestone as supplements to lower the cost. People stop and think about it. The PRB fly ash has a significant amount of alkali content, and it would be more effective if the size was reduced. And there are also industrial byproduct streams that are available to help lower costs. Next slide should be a picture of the equipment. I didn't mention, because I got disorganized, that we're talking about a very small footprint. This can be fit very easily in almost any power plant. Pictures here show metering pumps and a couple of injectors. Doesn't take much. We do need to do computer modeling to make sure we get the injectors in the right place and get good coverage. But the point is that you can clean up the flue gas with a very low capital cost. And that's the key issue. The only other comment I might make is that we are open to cooperation with folks to demonstrate the other things that we have not completely demonstrated, which is the HCl and the mercury.
Yeah, we'll open this up for questions, but the first question I have here is that since these particles are 0.7 of a micron, are you having problems with your precipitators or air pollution control equipment capturing the particles themselves?
We have not seen any problem with it, Bob, in the 3 tests that we've done. I think that we ultimately end up with agglomeration, but we have not seen anything. The precipitators have worked well, and maybe that point should be emphasized, because in the early work done by TVA and DOE, that was a major problem. And the reason it was a major problem was that they had very poor conversion of the lime that they generate to sulfates. In other words, the utilization was poor. If you increase the utilization, you don't have the adverse impact on the ESP that you otherwise would.
So that's a good point, that when you convert it to the sulfate, the particle size rises to substantially greater than that 0.7 of a micron.
There is still some free lime present. I mean, we don't, we're not 100% efficient yet. We know that we can improve the beyond that 84% in 2 ways. One is to lower the temperature of the gas, which has multiple benefits. And that will increase our capture performance significantly, but we have yet to quantify that. But the ESP aspect is obviously demonstrated.
Yeah, we've now opened the conversation up to everyone, so we have questions now for Jerry. the technology certainly seems to be cost effective. The one other question I have, what about the availability of supply? You said you can, for instance, use fly ash and things, so there's maybe ample amounts of supply with these various sources. Is that what I'm hearing?
There are multiple suppliers of present reagents. You're setting up to make products. They do that routinely.
Yeah, I'm going to have to put everybody else on mute again, and then I'm going to unmute mute you again, and get that last comment if you would.
The point I was trying to make is that there are multiple suppliers. We've got to qualify them to make sure they make the quality that we need, but there are multiple people who make these products. They actually do on-site preparation for the paper mills, so they're geared to coming in and doing service contracts. And any power plant that has an existing scrubber and ball mill is a potential raw material supplier to such a on-site process.
That's a good point. Well, Jerry, I'd like to thank you for that presentation. I'd like to thank all our other speakers and the participants. I think we've got a lot of interesting technology that we've been able to discuss for a couple hours here this morning, and we do want to explore each of these technologies more as developments occur. So we hope you will keep us posted, and we'll look forward to having many of you joining us for next week's presentation and those in the future. And this is Bob McIlvaine signing off for today.